For today's topic, we will discuss geometric sequence. Example number 1. Supply the missing terms of a geometric sequence blank 8 blank blank 512. So to think of this, since we don't have a sub 1 here, so temporarily we can treat 8 as our a sub 1. Since this is our a sub 1, 512 will be a sub 4. So first term, second term, third term, fourth term. And we will use the formula to solve the common ratio first. Okay, common ratio. This one. Okay. So we will solve the common ratio, and a sub n will be a sub 4. Okay, since that's the last term that we had. And a sub 1 is 8, common ratio unknown, and 4 minus 1. A sub 4 is 512 equals 8 times r raised to 4 minus 1, which is 3. Okay, then we have to divide both sides by 8 to remove 8. Okay, cancel out. Then 512 divided by 8 is 64 equals r cubed. Then to remove the third power, we have to extract the cube root of 64 and r cubed. Okay? Extract natin siya. So, cancel out. We can cancel out now the third power. So, cube root of 64. We just need to think the number that we need to multiply by 3 times by itself in order to have 64. So, that's actually 4. So, 4 times 4, 16 times 4, 64. So, 4 is our common ratio. Now, we can fill these blanks. So, these 2 blanks first. Okay, so 8 times 4, so is 32. Then, 32 times 4 is 128. Then, to obtain the first term, we just need to divide 8 by 4. So, we have 8 divided by 4, which is 2. So, example number 2. Solve a sub 1 and the common ratio r of a geometric sequence if a sub 5 is equals to 5 and a sub 9 equals to 3,125. So, a sub 5 is our first term since we don't have first term. Okay. And to make this as first term, we have to deduct this by 4 and deduct this by 4. So whatever you subtract here, so you have to extract as well in this term. So we have a sub 5 minus 4, so we have 1, a sub 1 equals 5, then a sub 9 minus 4 is now a sub 5. So 3,125. Now let's use the formula a sub n equals a sub 1 times r n minus 1. A sub n, so is 3,125. That's actually a sub 5. So a sub 5. And a sub 1 is 5. So common ratio unknown. N minus 1, so 5 minus 1. Then a sub 5 is 3,125. 3,125 equals 5 times r raised to the 4th power. So let's divide both sides by 5 to remove 5. Okay, so 3,125 divided by 5 is 625 equals r to the 4th power. So we have to extract both sides by 4th root. Okay, so remove 4, so equals r. So wala na yung variable power of 4. Then the number that we need in order to 625, once we multiply by 4, multiply 4 times by itself is 5. So 5 times 5 times 5 times 5 is 625. So that's our common ratio. Now, to solve a sub 1, we have two options. The first option is using the formula again, times Rn minus 1. So we have a sub n is, now we will use 5 as our last term, which is a sub n, since this is the smallest number and we already solved the common ratio. Okay, so we have 5 equals a sub 1, so that's actually that we are aiming to solve. Okay, so a sub 1, so common ratio 5 n minus 1. So yung ating n dito is 5, so okay, let's replace this by 5. So we have 5 equals a sub 1 times 5, then raised to 5 minus 1 is 4. Then we have to multiply this by itself 4 times. So by doing this, we will have 625. And to remove 625 in this side, so we have to divide both sides by 625. Then 5 over 625 is 1 over 125. And that's actually our a sub 1. So that's how we solve a sub 1 using the formula. We just need the common ratio, the last term, and the term position. Then we will be able to solve the a sub 1. Now the second option is the working backward. Okay. If we have 5 as our a sub 5, so as you can see, we have a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So by using the working backward method, we will divide 5 to obtain the previous term here, the a sub 4. Okay, we will divide 5 by 5. So since 5 is our common ratio, so 1. Then 1 divided by again by the common ratio, so we will have 1 over 5. Okay, 1 over 5. Okay. Then okay na yung fraction. Okay. Then 1 over 5. Okay, 1 over 5 divided by 5. So we will have the reciprocal of 5 over 1 since we have division. So 1 over 5. Okay, let's have here 1 over 5 divided times 1 over 5. Reciprocal of 5 over 1 is 1/5. So 1 times 1, 1, then 5 times 5, 25. Okay, so we have now 1 over 25. And 1 over 25 divided by 5. Okay, 1 over 25 divided by 5 is, okay, again we will have the reciprocal divided by 5. So we have now multiplication 1 over 5. So this actually equals to 1 over 125. 1 over 125. And that's it. This is the first term. So as you can see, we obtain the same result. So next example. Find the two geometric means between 2 and 128. So inserting two geometric means is just like this saying you are inserting two terms between 128. Okay? So as you can see, if we will insert two terms here, a sub 1 will be 2 and 128 is our a sub 4. So a sub 1, a sub 2, a sub 3, a sub 4. So meaning to say, if we will inject geometric three geometric means between 2 and 128, 128 will become a sub 5. So since we have to solve two geometric means, so this is the illustration. So now let's use the formula again to solve the example. So we have a sub n as 128 and 128 is a sub 4. A sub 1 is 2 r, then n is 4 minus 1. A sub 4 is 128. 2 equals to r raised to the third power. Divide both sides by 2. So we have 128 divided by 2 is 64 equals r cubed. So divide, extract natin by the third root to remove power of 3. Okay. So what is the cube root of 64? So that's actually 4 equals to r. So since yung ating r or common ratio is 4, we can now fill these two blanks. Okay. So 2 times 4 8, 8 times 4 32, and that's the two geometric means between 2 and 128. Fourth example, given that the first term of a geometric sequence is negative 4 and its last term is 236,196 with a common ratio of negative 3. Find the term position of the last term. So as you can see, it's just said that 236,196 is the last term, but the term position was not actually specified. So that's the thing that we need to solve here. So now we have to use the formula. Again, we will use the formula a sub n equals a sub 1 times r raised to n minus 1. And given the condition here in this problem is we have negative 4 as our first term and a sub n as our last term. Okay, then r is negative 3. So let's inject this in our formula. A sub n equals a sub 1. So okay, so a sub n is 236,196 equals a sub 1. A sub 1 is negative 4 and common ratio is negative 3. So negative 3 raised to n minus 1, we cannot actually fill or substitute any number in n since that's unknown. So 236,196 divided by negative 4. So we can negative 4 divided by negative 4, so cancel out. 236 divided by 236,196 divided by negative 4 is actually 59,049, and since we have positive divided by negative, this is actually negative. Then negative 3, copy lang natin negative 3, then n minus 1. We cannot actually divide negative 3, okay, both sides by negative 3 since negative 3 is raised by unknown variable. Okay, hindi pa natin alam yung value ni n. So to do this, to solve this, we will express both sides in exponential form. So this is actually already in exponential form, but yung ating right side of the equation is not yet written in the exponential form. So to do this, so we will rewrite negative 3 as our base. So we can actually solve the equation if we have two the same bases, no? So that's why we have negative 3. So negative 3, so we have to think the power of 3. So what is the power or exponent of 3? to make it 59,049. So that's actually 10, exponent 10. So 3 raised to the 10th power is actually 59,049. Then attach negative, then you will have 59,000, negative 59,049. So since we have two the same bases now, so we can actually disregard these two bases. So we have now, only have now 10 equals to n minus 1. Then transpose yung ating negative 1. Okay, so we have 11 equals n. Since ito ay magiging positive, so 10 plus 1. So that's actually the value of n. But the question here is the term position. So we have a sub 11 is equals to 236,196. So 236,196 is our a sub 11 or 11th term. So let's have another examples. A smaller number naman para we can actually, for us to be able to think the exponential form. Okay, so let's say we have a sub 1 equals to 3 and a sub n is equals to 12 and r equals to 2. Then we will determine what is the term position of 12 here. So a sub n, so we have to find the value of n. So now we have a sub n equals a sub 1 r raised to n minus 1. Then we have 12 equals a sub 1, which is 3. Then r natin ay 2. Then n minus 1. Okay, burahin natin ito. Okay, so n minus 1. So to remove, so we have to divide 3 both sides. Then we have 4 equals 2 raised to n minus 1. Then we have to express the 4 in exponential form. So base 2 tayo, since base dito ay 2. So we have 2 raised to n minus 1. Then what is the exponent? Ano yung kailangan na maging exponent ni 2 para maging 4 siya? That's actually 2. So 2 times 2, 4. So correct siya. So we have now to replace, disregard this part. So disregard lang natin siya. This one. Okay, disregard nyo na siya. Then we will only deal with the exponents. So 2 equals n minus 1. So transpose 2, so we have now 2 plus 1 equals n, which is 3 equals to n. So this actually the a sub 3, and n is equals to 3. So third term natin is 12. Okay, that's all.